Good afternoon. This is Mark Summers from Summers Technical Services. We're going to start our final big project. It's a top-down design, and it's an RF chassis. It's going to have a lot of RF components in there, some power supplies, and it's going into a chassis that's going into a EIA 19-inch rack. It's a custom chassis to go along with a bunch of other equipment to build a test system. And so we're going to get a chance to flex our muscles and do some actual design. So I'm supplying you with all of the purchase parts, all of the empty chassis, all the components you need. You'll just have to design your own bracketry, whatever you need, and modify the chassis as needed to make your assembly work out. So let's get started. So first thing we'll do is look at what I call the interconnect diagram. And here it is here in AutoCAD. So this is all stuff I've given you already in class. And so what the interconnect diagram does is schematically show the designer and the team. I call them the gazintas and the gazautas. So on the left side of the chassis, this is a view looking down from the top. It's not really a view, scaled drawing view. It's just a schematic. It just shows what connectivity is there between the components inside the box and the outside world. And so on the front panel, we've got 24 connectors, J1 through J24. These are feed-through bulkhead connectors. And then the W numbers are the wires that connect, cables that connect component to the component. So you can see those designations there. So this is a nice, convenient way to label components and label cables without labeling with the part number, because here it's just a functional interconnect. It doesn't have any part numbers. So we got some switches, switch 1 through switch 8. AR stands for RF amplifier. There's 8 of those. Those have heat sinks on them. We're going to need a fan on each side of the chassis, one blowing in one side and one pulling on the other. So I call it a push-pull fan configuration. You can do a push-pull configuration where you push air in from one side and pull it out the other side, running the air across the fins. You want to run the air across the fins to maximize your cooling. You can do a push-push and have the air come from both sides and then go up out through the perforated cover. So that's your call. And then there's 4 power dividers, and there's more connectors on the back side. So this left picture is the high-frequency signals. These are these 40 gigahertz high-frequency signals that are going to go through these SMA cables. And that's the connectivity for that. This other picture on the right is not a different chassis. It's the same chassis. It's just you can superimpose it on top of the other picture. So S1 through S8, those are not new switches. Those are the same switches. And what that part of the interconnect shows is the interconnectivity for the power and control as opposed to the high frequency signals. So unfortunately, our electrical engineer on the project is out this week, and he has not given us that interconnectivity yet. But he has got the schematic started, and there's some connectors we need to account for on the front panel. There's 4 connectors on the front panel and then 3 connectors on the rear panel. So go ahead and add those connectors to the ones that show up over here to learn what connectors go on which panel. What else? There's also a bunch of electronic components in this power and control chassis that are not shown on the schematic, but they're on the parts list, and we'll see those in a minute. And you're going to make a subassembly with all those components, and then hopefully when the EE information gets in, we'll figure out where that thing's going to be mounted so that it is located where the electrical engineer wants it to go. All right, so now we need to go look at the parts list, because we need to know which part is switch 1 and which part is switch 4. These are the reference designators, and this is what we call it generically, but we need to map the reference designators to the actual part that we're using, and that's where the parts list comes in. So let's get rid of that monkey man there and look at the parts list, which is right here. So this is the spreadsheet you have, and so what we have is an indented BOM. And so let's talk about what an indented BOM is. So this helps you understand how the parts report in the assembly. So you've got parts that feed into subassemblies, and those subassemblies feed into other subassemblies, and there may be some more parts that feed into that same subassembly, and eventually you get to the very top level. So the very top level is 0. That's our top level chassis assembly. Level 1 reports to level 0. So this is the modified Tekmar chassis assembly. This is the dash 30. So the dash 30 reports to the dash 10 based on that level number. Well, what's this? This is the level 2. Level 2 reports to the next level 1 above it. This is a purchased chassis from a company called Tekmar that we're going to use, or you're going to use, to create this modified chassis assembly. So this model I'm going to give you, and it's configurable so you can change the size. I'll show you what that looks like in a minute. But do not modify that part because we buy it. You're going to place that part into an empty assembly and call it a dash 30, and there you're going to punch your holes in it, add your PEM nuts that you need to make the dash 30. So 2s report to 1s and 1 report to 0. Now what's below this 2? Well, this is a 1. This is that dash 50 DIN rail assembly I was just talking about. And so the dash 50 is a level 1, so we have to go up until we find level 0. So this item here reports not there, but there. 1s report to 0s that are right above it. 2s report to 1s that are immediately above it. All of these 2s here report to the 1 that's the first one above it. So those number 2s report to that number 1. And then all of these 1s at the bottom, where do they report? They skip all these 2s. They skip the 1, the 2, the 1 that goes right to the 0. 1s report to the next 0 above it. 2s report to the next 1 above it, and so on. So this way you get the entire structure that you're looking for. All right, here's the quantities. Most of these quantities are correct, but maybe they're not. So make sure you take a look at that. Make sure they match the interconnect diagram. Cage code. What is a cage code? A cage code is how the government identifies vendors. And so if for some reason they're buying something from Summers Technical Services, I cannot identify myself as Summers Technical Services because there might be some dude in Kansas named Summers, and he's got Summers Technical Services, and so in the future they won't know who is who. And company changes names, companies change names, they get bought out, they go out of business, all that stuff. So the government says we're through with that. We're gonna use these cage codes, and if you want to sell to us, then you've got to play our game. And so let's go see how you can identify which company belongs to these cage codes. And so what's the first one there? 48GM4. All right, first thing we got to find a cage code search site. So I'm going to type in cage code. And I'm just remembering now that this is not going to work in Google. We have to go to inferior browser here. Let's try this one. So let's say cage. Let's go to Google. And we're going to type in cage code search. And this is what we want here. And I agree to whatever they want me to agree to. Cage search and inquiry. That looks like what we want. What was the cage code we're looking for? We're looking for 48. Where was it? 48GM4. 48GM4. You'll be doing this on all the parts you've got. And so, hey, here he is. Summers Technical Services. There's his DUNS number. There's where he lives, and we get details and find out all about me. So I'm registered on the CAGE, so it stands for Commercial and Government Entity Program. That's exactly what it is. It's just a numbering scheme to identify companies to a CAGE code, and when I sell something to the government, anybody sells anything to the government, they have to be identified by a CAGE code. All right, so now that's how you can find all these vendors, not the vendors, the manufacturer, excuse me, that makes these parts. So you'll need to look all those up. There's the part number, self-explanatory. There's a description. Here's the reference designators from the interconnect diagram. And so we're switch 1 through switch 8. It's right there. There's the part number, there's the description, there's a cage code, and there's a quantity. So you can look those up and find them. So now that we've got the ICD defined, the parts list defined, let's go look at the data that I gave you in class. We've got three things. We got handouts, we got data, we got models. So under handouts, you've got all these data sheets. I'm getting nice in my old age. I'm giving you all these data sheets. So if you want to find out about the LED, you can double click on the PDF file and open up the data sheet and learn about how to mount these LEDs. And it gives you the part numbering scheme and everything. So you'll need these data sheets to find out what your parts look like. Create your structure on your computer to match this. You're going to have an A11 RF chassis folder. That's where all your custom Solidworks files are going to live. Inside that folder, you have a handouts folder, a data folder, and a models folder. Create it just like this, otherwise you're going to be in a big world of hurt as you move forward. So under handouts, like I said, is the data sheets. Under data, I've got the ICD and the parts list we just looked at. And under models, there's three folders: Arduino, components, and TechMar. TechMar contains all the parts for the TechMar chassis. I'll show you that in a minute. Components are where all the components live. These are CAD models of every one of those components on the ICD and on the parts list. So I've given you all this stuff. Make sure when you place these files, you look. Here's one that's got multiple files with the same part number, PE9184. Don't place this one or this one or this one or this one. These are all parts that roll into this part assembly model here. So if you got one with multiple names that match, make sure you place the assembly. Otherwise, you're going to have just a nut or an O-ring instead of the whole connector. All right, so those are all the CAD data. And then what else we got? Arduino is an Arduino we may or may not use. So there it is. All right, leave those in those folders. Don't move them. All right, what else? All right, let's talk about the tree, what I call the tree, product structure. Would be a better way to think about it. So when we build our CAD model, we want to build it exactly the way it's going to be manufactured on the manufacturing floor. And so let's define this structure so we get it right in the models, because fixing this after the fact is very difficult. All right, so let's start off at the top level. The very top level is always going to be the assembly drawing. So I'll call this the -10 assembly drawing. All right, and then right below that is the -10. Let's make this green. -10 assembly model. So the -10 assembly model is going to report to the drawing just like it did on our previous assembly assignments. What feeds into the -10 assembly? Well, we've got another assembly called the -30 modified chassis assembly. So that is the TechMar chassis that gets holes poked in it. So that's going to be another subassembly you're going to make. What reports to the -30 modified chassis, you ask? Well, that's easy. It's that TechMar chassis. So that TechMar chassis we buy and we don't touch it. It stays in its own assembly. It reports up to the -30, and then you punch holes in it, add pin nuts, whatever you need to make the -30. And then this last assembly over here is the -50 DIN rail assembly. And what goes on the DIN rail assembly? Well, a bunch of parts. So let's get a different color here. And it's going to be, I don't know, I can't write it in here, but we'll call it Phoenix Contact Part 1, Phoenix Contact Part 2, Phoenix Contact, Phoenix, Yeah, Phoenix contact part 3, and then dot, dot, dot. All of those parts report to the dash 50, and then the dash 50 reports to the dash 10. What are these other components up here? These are more parts, so I'll leave those orange. This is we'll call it component 1. This is component 2. This is component 3. Component 4. Dot, dot, dot. Those are all the components in that component folder. Excuse me. Switch, power divider, all of those components feed into the dash 10. You have to build your CAD structure just like the product structure to make all this magic happen. And if we had I will leave it at that. So that's the product structure. All right, now what are we going to talk about? Let's talk about how we do this in Solidworks. So I just happen to have Solidworks running here. I'm going to start a new assembly. I'm going to build this structure just like I talked about. File, new. I'm going to get an inch assembly template. Move my iPad over here so I don't break it. All right. And we're going to place, I want to make the dash 30 assembly. And so I'm going to place RF chassis, models, TechMar. Here's the assembly. I can use my filter so I just see assemblies. These are the assemblies that go into the big assembly. This is what you want to place in the dash 30. TechMar Basic Series. I'll say open, and I'll place it. Boom. All right, now what do I do? I just save it. I do a file, save as, and I'm going to call it, I'm going to put it in this root folder. I'm not going to put it inside his models folder. I'm going to call it, using our normal scheme, it's assignment number 11, right? Dash 10. It's a dash 10 assembly. Oop, no it wasn't. It was a dash 30. My bad. So the dash 30, going back to our tree over here, this is what I'm making the dash 30, so I already screwed that up. So I'm going to come up here and say file close. It's not reporting anywhere, so I can go file open and rename this thing to a dash 30. All right, good recovery, Summers. All right, so the dash 30 contains the TechMar chassis. Now I'm going to create a dash 10. What goes in the dash 10? The dash 30. So I'm going to say file new, start a new assembly. And place the dash 30. Whenever it comes back to life. File new, there's an assembly inch. And it's going to pop up and ask me what do I want to put in there. And since I've got the dash 30 open, I'll just select the dash 30 and place it in the assembly. Now, I haven't done it, but make sure you go in there and float these things and then line up the assembly planes to the assembly planes for the chassis so all those planes line up. So once I do that, then I'll say file save as, or save, it doesn't matter. Save, it'll get me in the same place because I've not saved it before. And this one's going to be the dash 10. So now I've got a dash 30 that reports to a dash 10, and I want to do the same thing with my dash 50. You're going to make a dash 50. You're going to start a new assembly model. You're going to place the DIN rail. You're going to place the power supply, all that Phoenix contact stuff in there, and you're going to call that a dash 30, and you're going to have that report to the dash 10, just like I have the dash 30 reporting to the dash 10. Once you get that structure set up, you're going to want to have me take a look at it, because if you get this wrong, it's going to be painful to fix it later. All right, so we've got one chassis in here, and I'm at the dash 10 level. This is where I want to put my components in there, so let's see how we do that. First thing I'm going to do is open this thing up. I'm going to find this lid, and I'm going to temporarily hide it. So it looks like it's this assembly right there. That's the lid. And I want to be able to look inside to place my components, so I'm going to temporarily right-click and hide it. So that looks nice. And then maybe the other thing I'll do is I'll find the assembly for the front panel, because maybe I want to look here and I want to kind of see through it to look inside. And so I can do another trick. I can right-click and say change transparency, and that looks kind of cool. I can see right through it. All right, so you can do stuff like that. Now let's say we get halfway through and you start putting components in here, and all of a sudden the chassis is too small or it's too big. And it'll be one or the other, because it'll never be right the first time. So what you'd have to do in the old way would be to delete this chassis along with all the mates and then place another chassis. That sounds like a lot of work. And so what I've done is configured this Tekmar chassis assembly, which is inside this -30, which is right there. And so if I don't like the size of that chassis, I am going to right-click on it and go to this component properties, and I want to choose a different configuration. Right now I've got this configuration, so let's go through the manufacturer's part number scheme so we know what this means. BK stands for basic kit. That's what Tekmar calls this particular chassis model. 5H means it's approximately 5 inches tall. 18D means it's approximately 18 inches deep. WHR, I think, stands for these. It tells them that you want these side holes. I'm not sure what it stands for, but you get these side holes. And these side holes is where the shelf mounts to. So you can mount the shelf down here or in the middle or at the top, depending on where you want it. And then 1PC, I think that stands for one perforated cover, which we've got on the top. And I think the CBP gives you these handles. So you can look on the Tekmar website, you can read how they do all that stuff. But say I want one that's a little shorter. Well, I can get the 3H 18D instead of the 5H 18D and say OK, and it's going to go in and reconfigure this thing to give you that smaller chassis. And if you want a little longer chassis, you can right-click again and go to the component properties. And let's go to a real tall one. It's real deep. I'll go to a 7-inch tall, 24-inch deep. It updates everything automatically, which is really, really nice. And so you can change that size as you need to. You got to make sure you got enough room for the fans to fit in on the inside of both sides. The fans mount on the inside. Finger guards go, a pair go on the inside, and a pair of the finger guards go on the outside. And there you can see that chassis is mounting to those holes there. So I think most of you are going to leave that chassis there, the shelf there, because you're going to need that height above. All right, let's throw some components in here and kind of get a feel for how we lay this thing out. So we're not going to be drilling any holes. We're not going to be putting fasteners in here. We're just going to start placing components to get our design right. Once you get all the components in there located, then we'll have a design review before you move on to start punching holes in things. So let's place some components. So I want to go to the parts list. Go to the parts list, which is right here. I'm going to find those switches, and it's a RFSP. And so I'm in the -10. I'm going to insert components, browse, and I'm going to go find that component folder. And I'm so nice, I gave you all these models already. What was the part number? Is that it right there? Did I not get it? I hope your computer's faster than mine. Ah, here we go. Boom, there it is. All right, so we need to locate this thing. Well, let's look at the interconnect diagram and see which way it's supposed to be oriented. It's got 3 connectors on the front, 1 on the back. Those 3 need to face the front. Okay, I got it. Now let's go back over here and let's mate this thing. So I want to put this thing, I've decided I want this thing to mount to the shelf. So I'll be drilling holes or putting pin nuts in there. So I want to mate those 2 faces together. And I'm also going to put a parallel mate because I want this thing to line up with the chassis. So I'm going to go find the front plane, or the right plane of the chassis. You can see that plane's in the wrong spot because I never floated and fixed those chassis, so I know you're going to fix that on yours. I want to go from there to there. I've got planes in strategically located spots. I don't want coincident, I want parallel. And that's enough for now. And what that lets me do is drag this thing around to different places. All right, I need to have 7 more of these things. I could place 7 more, but I want these things to be grouped together. So I'm going to do a linear component pattern. And so I'm going to close up my tree a little bit. Managing this tree becomes a chore. I'm going to select that component. I want to come up here and do a linear component pattern. I pre-selected the part, so it's in the list. Direction 1 is going to be, I can choose whatever feature I want, but I'll use that right plane to define the direction. Distance between them, I don't know, make them 3 inches, and I need 8 of them, right? What happened to my 3-inch thing? There we go. Okay, boom. Now I'm golden. Well, not so much. Now it doesn't fit in the chassis. So what do I need to do? Well, I can make a wider chassis. Well, there's no wider chassis. They're all standard 19-inch widths, so that's not going to work. What could I do? Well, I could do 4 and 4 stacked up this way, or I could do 4 and have 4 behind it. I could do a lot of different things. But maybe I look at it and say, well, maybe I could squeeze these a little closer together. I don't have to necessarily get into the side here. The screws are on the top, so let me edit this pattern and make them spaced 2 inches apart maybe. So this is what you'll be doing on all these component placements. And now all of a sudden, hey, I think I'm happy here. It looks like they're all going to fit. Now I can locate this thing. So if these are 2 inches apart, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 inches all the way across. Well, if I want these centered, I want the center plane to be right here. And so how far would the center plane be from this guy here? Well, if this is 2 and this is 2 and this is 2, then from here to the center plane, which is halfway between these two, is going to be 2 plus 2 plus 2 plus 1, which is 7. So I want to come in here, grab the middle plane of this part. I want to edit that feature I already had. I want to delete this one, or edit it. And I'm going to switch out this plane, so I'm no longer pointing to the overall right plane. I want to point to the plane of the dash, plane of the dash 30, or in this case the Tecmar chassis. So there is a middle plane there. So I want that to be 7 inches, so I'm going to say mate. And I didn't get the number in there. Where is that mate? Right in here. Oh, leave me, Maverick. Here we go. There's the mates for that part. I need to edit this. This is kind of clumsy here. What am I doing? Here it is right there. Edit feature. I've got the right planes, but I need to make this coincident. And then I need to put this dimension in here. I need to click the dimension number and now put 7. Now that thing is perfectly in the middle. And I don't have it located. It's still loose front to back, but at this point that's okay. And so you just keep going. You keep putting components in there. You keep monkeying with them, move them around. Have enough room, don't have enough room. Stack them. Do whatever you need to do. You don't want to do silly things like put this component at the very back corner over here and then put this component in the front corner up here. Then the cables are going to be a big rat's nest. So use logic, use common sense to get the things located in a way you can route the cables, because eventually you have to route the cables on all these things. So I think I've gone through my list of things to do. Start placing components. You won't have any idea where they're going to go until you start placing and move them around, and constrain them as much as you need. You don't have to constrain them all the way right now, because eventually we're going to constrain those switches and all the other components to holes you're going to drill in the chassis. But step one is to get all the components in there, and maybe I'll do one more. Let's put this front panel connector on there. So I think that was this guy here. Where's the assembly? Washer, where is the assembly? There it is right there. And sleep. There it is. Alright, so there he is in there. This thing needs to mount onto the front panel, and so I'm going to, can I select that face? Yes, I can. That face is going on this face, mate, and it's oriented the wrong way. That needs to go 180, so I'm going to flip it. There we go. And maybe that's all I'll do for now. Maybe I don't know where it's going to go, so I'm just going to leave it loose, kind of like I did that first switch. And now what do I want? Well, I got to have 24 of these things. So I can do, what can I do? 24 across. I could do 12 by 2, 8 by 3, 6 by 4. I can do whatever I want. And so I'm going to do another linear pattern. So there's the part, linear component pattern. The direction, I got two directions. And so direction 1 is going to be side to side, which I can define by that perpendicular to that plane. Direction 2 is going to be up and down, so that's going to be the top plane. And I can make 2 and 8, and I can make 2 and 3. 2 inches, 3, so that's 3 times 8, that's 24 of them. It's going the wrong way, so I'll flip that one and say okay. And I don't know, it looks pretty good, but now I may not fit. It looks like it's hitting the shelf. I got to get those other connectors on there, so maybe I need to start scratching my head and thinking some more. And so leave it loose like this until you get everything located, and then we'll come back and drill holes and locate those things. All right, that'll get you started. This is our final project, so we're going to go to the finish line. Nothing but this every class period, so get a fast start, because it's going to take you a while to make all these, to get this assembly going. We'll have a design review, then you'll start punching holes and mounting everything, and then you're going to start routing cables. So we got a lot to do, so let's get started on it. So again, this is Mark Summers from Summers Technical Services. Thanks for watching, and watch for follow-up emails on this exciting new project.